Okay, good afternoon. Am I audible properly? Okay, so if suppose I will get disconnected in between, just do not leave the session. I will rejoin because of internet and electricity. I have joined through mobile. So if I will get disconnected, just I will be back in a minute. Okay, so we'll start. Just tell me if you are getting a screen. Are you getting the screen? Okay, we'll go ahead. Right. So the last lecture we just left in between, so we'll continue. So we are dealing with the last part of the chapter, that is the monomers, polymers, and the polymerization and the applications of plastic. So from the start, we have started with the basic of plastic materials, then its properties, based on the properties, different types of applications. Applications that are based on the its chemical structure or the structure. And at the end, we'll see the properties that are based on the area of application. That is the difference. Okay, so that application are twice here. Right. So the first part in the last lecture we saw about the monomers. Simple definition I have given you that time. Okay, one more thing. If I will get disconnected, if you are not getting the screen or my voice, just unmute yourself and tell me. So we deal with the monomers in the last lecture. Right, monomers that I told you also. It is simply as like a building block or unit cell. In a chemistry language, it is called as unit cell, a simple unit. And if similar example, if I want to give, it will be like a brick. Right? A brick is like a unit or a smallest unit that creates by combining a number of bricks that will create a structure, a building. If you see at the building in that that particular brick, a single brick is a unit cell. Similarly, in any plastic or any material, this unit cell or the monomer is a basic unit or building block, right? So here only the case is that in case of plastic, it is this unit cell which will have two or more binding sites. The condition is only that it should have two or more binding sites, because the reason that I told in the last lecture is that just simply a monomer will not have any existence, right? See, a simple brick is not having any existence or any importance. When a number of bricks will come together, it will have a binder material in between them, and then it will create a beautiful structure, right? A beautiful building. So in a group they will have existence when they will combine together by using some binder material. Similar way, the monomers itself will not have an existence. It will, but that is of no use. Rather, the polymers are of basic use, or polymers are used in different applications. So monomer is a basic unit of that. Only condition is that it should have two or more binding sites. Binding site stands for binding site stands for the link will continue from that end. Okay, so here example is given. Okay, so here example is given. This carbon is having two binding sites, one at the right side and one at the left side, and this chain will continue like this. One from the right side there will be attachment, and one from the left side, and that way it will create a polymer. Okay, polymer stands for when monomer will combine together, it will create an polymer. It's like a chain. So here it is given polymer, any class of natural or synthetic substance composed of very large molecules. So micromolecules will come together and will create a macromolecule. Okay, micro is the smallest, macro is a larger part of that. Okay, when it will come together, it will create a large unit that is called as macro. So micro and macro. Micro is the smallest one. Right, so that polymer is of more importance, and here the example is given. There is a polyvinyl chloride, PVC, polyvinyl chloride, exactly. Now you can see here, right? CH2CHCl is the unit cell or monomer, and that is continued like this, one from right side, one from left side. So whatever it is shown in the dotted line, that is the unit cell or the monomer, CH2CHCl, that is called as a vinyl chloride. Vinyl chloride, and that vinyl chloride monomers will combine together and create an polyvinyl chloride, which is popularly known as PVC. PVC. Okay, so whatever plastics we are using, that are actually polymers. That are actually polymers, and the process of creating or preparing polymers from the monomers, process of manufacturing or preparation of polymer from the monomer is called as a polymerization. Okay, or you can consider like an addition of monomers, linking of monomers is called as a process, is called as a polymerization. Product is called as a polymer. Getting it? Product is a polymer, process is a polymerization. Small molecules will come together, will form a macromolecule, which is called as a polymer. Okay, now in that case, the polymers that are there, that are going to be there in a chain, may be of similar type, may be of dissimilar type. Okay, here in case of polyvinyl chloride, you will see that all the monomers are of same type. Okay, but it need not to be. Okay, it can be a different also. Now there are two different types of polymerization. First is addition polymerization, and second is a condensation polymerization. One is a addition polymerization, and second is a condensation polymerization. Okay, simply the word itself is explaining the method of polymerization. Okay, in case of addition polymerization, addition of monomer will be there. Now don't think in a way that like a physical addition. One monomer, you will externally add one more monomer in that, one more monomer again in that system. That will not. See, addition is a here chemically. That means a chemical reaction. Addition in the form of chemical reaction that will create a polymer. Okay. So one will be an addition polymerization, another will be of condensation polymerization. Now repeated addition of monomers, simple addition, is called as addition polymerization. Is called as addition polymerization. There is no such any complicated process in case of addition polymerization, and no any byproducts also. In case of condensation polymerization is a complex chemical reaction, whereby you will get the byproducts also. Now, the meaning of condensation, many times you have seen that condensation in the thermal engineering. Okay, once anything will get vaporized, suppose if you supply the heat to the water, it will start boiling. When it will exceed its boiling temperature, then it will start vaporizing. When you will lower down the temperature, that vapor will condense to a liquid. Vapor will condense to a liquid. It will come down to its original state. That's phase transition is called as a condensation. That phase transition is called as a condensation. Similar kind of condensation reaction will be there to convert monomers into polymers. Okay. Now, but the basic difference is that in case of addition polymerization, being a simple chemical reaction, there will not be any byproduct. There will not be any byproduct. Okay. But in case of condensation polymerization, there will be a byproduct. So byproduct means it is of no, there will not be any place for that particular product in a final application. Okay. Now that's why this difference you will find here. First thing, addition polymerization, simple addition, simple chemical reaction, so no byproduct. In case of condensation polymerization, mostly like an HCl or water used to be an byproduct. Now this will result into change in its into molecular weight. See, In case of addition, what is going to happen? Simple addition, 1 plus 1 plus 1. It will become a 3. There is no byproduct, so addition of 3 monomers will become a 3. Just consider it in a form of numbers. Addition of 3 monomers will result into 3 monomer chain or polymer chain. But in case of condensation polymerization, these 3 monomers will react together through the condensation polymerization, and one byproduct will come out. Obviously, there will be one major product and another will be a byproduct. We are going to deal with only major product, so byproduct is of no use. So what is going to happen? So here 1 plus 1 plus 1. These 3 monomers will create a polymer with the molecular weight of suppose 2.5 and byproduct of the molecular weight 0.5. Total it is a 3. But that byproduct will take away some molecular weight. So what is going to happen? A final molecular weight of that polymer is not equal to addition of molecular weight of all monomers. Getting it? Because of the byproduct. That byproduct will take it away some of the molecular weight. So final molecular weight be not equal. It will be less. So in case of addition polymerization like polyvinyl chloride, polyethylene, Teflon, the routine products that are coming from addition polymerization, and the bakelite, nylon, silicon, these are from the condensation polymerization. Now in case of additive polymerization or addition polymerization, there are 4 basic subtypes. Okay, very simple. Just consider that there are 2 types of monomers. One is of capital M, another is of capital N. Here I have given. Look at here. 2 types of monomers. For example, one is of type M, another is of type N. Okay. So in case of Homo polymerization, there will be a chain of similar kind of monomers, M, 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 M. So if it is a vinyl chloride, so all the monomers from that polymer will be of vinyl chloride. Getting it? Okay. So it will be a similar or same type of monomers which will combine together and form a chain that will be called as a Homo polymerization. It may be M, 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 or it may be N, N, N. This M and N stands for a simple monomer. Okay, the name is given. So Homo polymerization means same type of monomers will form a chain. Now, in case of copolymerization, second type. In case of copolymerization, there are 2 subtypes, random and alternative. Now, co stands for mixing of monomers. Mixing of monomers. So we have considered 2 types of monomers, capital M and capital N. Now, in this case, what will happen? According to the type, there will be a chain. So suppose random type. Random type means what? This M and N will mix anyway. M, N, M, M, and N, M, N, M, like this way. Or N, 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 M, 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 like this way. So there will not be a proper structural or proper structure for the mixing of these monomers. So randomly it will form a chain. And in case of alternative layout, monomers will be alternative. See, alternative in the form of like Mn, Mn, Mn. So one monomer of first type, second will be of second type, third will be of first type, fourth will be of second type. So alternatively it will be attached in the particular chain. Okay. So homopolymerization, similar types of monomer. Copolymerization, either it may be a random type or it may be alternative type. Third is the block polymerization. So it is again a type like an alternative type polymerization in case of block polymerization, but it will form in the form of groups. It will be in the form of groups. It is a kind of alternative polymerization, but in the form of groups. So here in case of block polymerization, what is going to happen? A group of first polymer, then second place, group of second polymer, third place, group of first polymer, fourth place, group of second polymer. Okay. So here it is given example like triple M, 4 times N, 4 times M. Okay, so these M and N are separately forming a group, like a blocks, and then these blocks are connected together. Okay, so first Homo, similar type, then copolymer, either random or alternative, and block, alternative but with the groups, and third is like a graft. Okay, now this graft is a regular word, like we generally go for a grafting of flowers also, grafting of flowers. Okay, similar way, here also this is a graft polymerization. Okay, so what has been here? See, there is a chain of M type of polymers, monomers, M, and whatever this red colored M is shown, that is a grafting process, right? Like in case of rose flowers also we have gone for the grafting, right? Root may be of the red color rose, and you are making the grafting of pink color rose, getting it? So ultimately a new product you will get that way. Okay, a base or basic backbone will be of different monomers, and on that platform there will be a grafting of another monomers. So basic backbone of chain is here of M type of monomers, but there is a grafting of two different types of, not required to be two, it can be multiple also, two different types of monomers. Okay, different types here at the bottom I have given. This M stands for a group of N type of monomer, so it is totally different type. Okay, so backbone or basic chain is of M type of monomers, and grafting is made for the N type of monomers, getting it? Okay, so four basic types: Homo polymerization, similar kind of monomers; copolymerization, either randomly placed or alternatively placed; block polymerization, again a similar kind of alternative polymerization where monomers are placed alternatively but in the form of groups; and in graft polymerization there will be a basic backbone chain of single monomers, and that polymer chain, similar kind of polymer chain, grafting of different monomer is made. Okay, that way it is called as graft polymerization. Okay, so we'll revise once again. The first part, monomer, a simple or single or basic unit cell, a single unit cell having two or more binding sites. Important. Polymer, when monomer will combine together it will form a chain that is called as a polymer. Process of converting monomer into polymer is called as a polymerization. That will be of two types: additive, condensation. Addition will be a simple addition reaction, and condensation will be where uh, two different types of bifunctional or trifunctional monomers will be there. In case of addition polymerization, no byproduct. In condensation, there will be a byproduct. So that in case of addition polymerization, molecular weight of total monomers equal to molecular weight of polymer. In case of condensation polymer, total weight of monomers may not be equal to total weight of polymer because of the molecular weight carried away by the byproduct. Four basic types of additive polymerization: Homo polymerization, similar kind of monomers; copolymerization, randomly placed or alternatively placed monomers; block polymerization, alternatively placed monomers but in the form of groups; and a graft polymerization, a backbone of similar kind of monomers whereby grafting of different kind of monomers is made, right? So this was regarding the monomers, polymer and polymerization. Okay, so in your exam there will be a question like this: what is the meaning of monomers, polymers, and explain in detail about the polymerization. So in that case you will have to define monomer, polymer, polymerization, and just differentiate and give the its subtypes classification. Now the last part is the regarding the applications of plastic. Now here, see, if you see the syllabus, don't get confused. Okay, now here already we have gone through the applications of the plastics, like polyethylene, polycarbonate, polypropylene, ABS plastic. Okay, so that was based on chemical structure of plastic. Okay, just an overview of the different types of plastic we have seen for different types of applications. Okay, and from the start only, I am telling you that everywhere in each and every field you will find the application of plastic. Okay, from morning to the evening. Okay, so everywhere you will get whatever product you will handle, some kind of uh, plastic you will find in that particular application. Okay, it may be the toothbrush for with which your day starts, your mobile, television sets, laptop, PCs, tables, chairs, everything. Okay, so everything you will find the application of plastic. Now we'll see the area wise application of plastic in a area wise. Okay, and the first major area, let's see now. Okay, here are some of the areas that we are going to focus. First is an agricultural area, then packaging, the most widely used, the plastic is mostly used in this packaging industry. Okay, building, transport, electrical and electronics, and furniture. This some of the basic areas we are going to focus. See, as I told, everywhere you will get the plastic, but the major applications we will see. Okay, there is no any limitation for enlisting of the applications of plastic. If you check out, it will create a very long list. But some of the major applications we'll see, and we'll start with the most important one, that is the agricultural applications. Okay. Now, in agriculture, you will find numerous applications of the plastics in the agriculture, in the form of polyvinyl chloride, vinyl acetate, polymethylene chloride. Okay, and so many others. Polycarbonate sheets are also there. If you want to see the major one, the first thing that you need to understand why plastic is used for agricultural purpose. See, in between I told you that there is a ban for the plastic also, like to use the carry bags, polyethylene bags, to use the polyethylene bags, and even in the last 6 months before, government has banned your PET bottles also, polyethylene tetraphthalate, whatever the plastic bottles you are using for drinking the water, Bisleri, okay, so that oxygenated water bottles, even the milk bottles, cold drink bottles, everything that is coming is the polyethylene tetraphthalate, PET bottles. So government is planning to ban that also, plastic bottles. Okay, so many reasons. Mostly related to the environmental, okay, and the animals also. When if you see when animals will eat that particular polyethylene carry bags, okay, it will create a very like if you see, many times it was found that when that cow or buffalo will eat that polyethylene bags, it will totally disturb their internal intestinal system, digestive system. Okay, so because it is of a chemical nature, so that in the first instance polyethylene is banned, so that in many of the shops you will find paper bags, paper cups, paper sheets, paper plates, right? In the parties also you will see the paper plates, but polyethylene is at the some level it is not there any use. But in agriculture you will find there are so many applications, right? So here are some basic important points are have given, which is supporting the use of plastic in the agricultural. The first is the water can be saved. Okay, now there are, see, we are all from the rural background. Uh, to carry the water from the well or the bore well, water is mostly carried from well or bore well to the, or that electrical motor to the place where it is required. Okay, and there are two ways to carry the water. If it is of a longer distance, PVC pipes are used, polyvinyl chloride, PVC pipes. You check it in old days. Old days, that iron pipes are used, are in use. So that iron pipes it is transferred from one place to another place. You can see also the water from the reservoir is transferred to the longer distance through the canals, getting it? Okay. And if you see the quality of the water at the source point, that is at the reservoir, and the end point, end of the canal, check out the quality of the water. And again, if you see, there is a huge wastage of water if it is passed through the canals. With respect to that, if you transfer that water, if you carry that water by using large pipes, PVC pipes, okay, so that will save that particular water. Not in case of the canal also, in case of regular agricultural applications also. Okay, PVC pipes are used. Okay, but the basic purpose is that to save the wastage of water. And the temperature can be maintained under the covers during the night. Okay, photo selectivity can improve, plastic irrigation pipes, pesticides, greenhouse, everything. Okay, why I'm reading it fast? Because here are the applications with picture, you will understand easily. The first one, greenhouse. Okay, and I think I need not to explain so much about the greenhouse, use of the greenhouse and the profitability of the greenhouse. Getting, see, uh, most of the vegetables nowadays, now this culture has started in our India also, but the advanced agricultural, if you want to see, the Israel is the best country where there is a scarcity of the water. They are using sea water for the agricultural, obviously by processing it. But the yield that they are getting through that particular specific land is much more higher than the yield that we are getting in the India. Okay, so they are using this technology, greenhouse and irrigation systems. Okay, so basic use of greenhouse, you are aware of that also. The thing is that whatever there is a temperature difference in the atmosphere, that is mostly affecting the yield of the crops, and the temperature difference is causing so many diseases also, infections. Okay, the viral attacks on the crops. Okay, you have seen that green cloth on the grapes also in agriculture. Okay, grapes and so on the so many crops, or a white type of cloth. And this is a structured greenhouse. So in that greenhouse, one can maintain the temperature. Okay, farmer can maintain the temperature as per the need of the crop. Disease attack or viral attack will be negligible. I will say it's a zero. Okay, and ultimately requirement of the water, requirement of the fertilizers, requirement of the chemical, everything will be a very less, very less. So that, so that these greenhouses are in use. Now this entire structure of greenhouse is made from the plastic. That obviously that cloth is of plastic, and whatever the fabrication structure is there, pipes, sometimes you will find it made from the iron pipes or steel pipes, and sometimes it is a PVC pipes, but mostly they are using PVC pipes, because iron or steel pipes, again, it will be a costly. And you know the cost of the greenhouse, even a small greenhouse is not costing less than 10 lakh rupees, right? And even government is supporting for such things. The government subsidy is also there. So there are so many uses of this particular greenhouse. So that greenhouse uh, mostly made out of the plastic. Second application, low tunnels. This also you have seen. Okay. Now it was not there earlier in our country, but looking to this applications in European countries and Israel and America, we have also started using of this. Okay, load tunnels, you can consider this as a micro structure or the micro picture of the greenhouse. Greenhouse will be at the larger level and this will be at the lower level, less costlier and for temporary use. Okay, nowadays this is also used mostly for vegetables purpose, vegetables or other crops also, right, or fruits. So this low tunnels again same use. Disease attack or viral attack will be less, requirement of the water will be less. Okay, so because of this, these low tunnels are used, also made of the out of the plastic. Mulching paper, this is not new to you. Okay, mulching paper. Okay, it will reduce down the need of the water for the particular crop. Mulching paper made from the plastic. It's polyethylene, right? It's a polyethylene. Obviously not a pure polyethylene, right? You have seen this. So it will expose only to the only that crop part will be exposed. The remaining land will be covered, so that there will not be an another plants on that particular area. Okay, only that required crop will be there. Same use. Okay, because of it will avoid water evaporation also. So requirement of water will be less. Also the chemicals will required will be less, and obviously yield will be more. So three basic applications that are used in nowadays: greenhouse, low tonnage, and mulching. Irrigation system. It is inside drip, outside drip. Uh, then there are so many types of this type of irrigation systems, and you know the drip pipes. If you have seen, it is totally a black colored drip pipes made out of the plastic. Okay, you have handled it also. So major application, and you know the use of the that drip irrigation also, because scarcity of the water, it is very useful because of the less requirement of the water. Now this silage, quite new concept for you, but if you see the European agricultural, this is used as silage. Just look at the picture. I will zoom it. Now you will understand what is there in the silage. Silage actually, this is a dried crops, dried crops. Okay, see, like in a summer days, there is a actually the problem of the water, and the green fodder is not available. Green fodder is not available in the summer days, so this is a dried fodder. Okay, if I want to say in मराठी, like आपण ते तुरीच्या वगैरे जे राहिलेल्या खाली हे असतात काड्या असतात, गव्हाच्या काड्या असतील किंवा सोयाबीनच्या काड्या असतील. ओके, सो लाईक ज्वारीचं जे खालचं रूट्स असतात मोठे, त्याला आपण कडवा म्हणतो. ओके, दॅट इज युज्ड ॲज अ फॉडर फॉर दी animals. Okay, so this silage is a concept like we are storing it in a as a like group. Okay, we are storing it in a open space, but in European countries it is made as like a silage. It is crushed okay, so it stored for a longer time. Whenever required, it can be transported easily also. So this is a dried fodder. Okay, and this plastic is saving it from the maybe rainwater or excessive temperature. And this, so many applications of plastic. This is a crate. Okay, we call it as a carrot. Well, crate. Simple, made from the plastic. Used to carry the fruits. A simple use, but there are multiple uses also. Okay, but crate which is used in agricultural is also made from the plastic. So there are only I have focused. The smaller applications, so many equipments are made from the plastic which are there in a agricultural. Okay, so I have Okay, other plastic applications. Now, again, second major application. Second major application is the packaging. Okay, in the start also we have seen the packaging applications of the plastic. The basic one came from this packaging paper, which is made out of the plastic. PET bottles, banned but a major application. Now all types of bottles are shown here, starting from your drinking water, sanitizers, shampoos, and cheese and whatnot, cold drinks, everything will come in this polyethylene tetraphthalate. Okay, this is known only with the chemical name PET bottles. Okay, it is called as PET bottles, used for the packaging of the liquid or semi-solid uh, food products and chemical products also. Carry bags, polyethylene bags. Okay, polyethylene bags, chemical name is a polyethylene bags for the carrying purpose or the packaging purpose. Liquid containers, high density polyethylene or sometimes low density polyethylene also. Okay, these liquid containers used for the packaging of the chemicals, liquid fertilizers, so many things. Okay, food packaging, this paper you have seen. Okay, already I had discussed with this. Okay, so for every type of packaging, mostly either a cotton cloth or this plastic is preferred. Okay, so as far as life is concerned, this cotton is having the problem. So that plastic is mostly preferred for all types of packaging. Okay, and nowadays paper packaging has also come into the picture because of this undisposable nature of the plastic. But still, it is widely used for all types of packagings. Even your milk is also coming with milk bag. Blood, if you see it in a hospital, blood bags are there. Okay, so that blood bags are polyethylene bags. Okay, so that every type of packaging, you will see the application of this plastic. Transport application. Need not to explain much more. Just take an example of any vehicle. A windshield wipers, driver partitions, instrument panel. If you see the four-wheeler instrument panel, that is also made from the plastic. Or the two-wheeler. Uh, now, I think around 95% part of the two-wheelers are made out of the plastic. Mudguard is there, head is there, then indicators, right? Only major things, petrol tank, that's tires that are made from the different material. Otherwise, everything is made out of the plastic only. Headlights and all. Okay. Mirror cases, interiors, sitting. Okay. Again, headliners, cabinets. So in transport also, because of less cost and less weight, it is mostly used in the transport. Okay, but obviously where there is a requirement of or when huge load is required to carry, that time it will have limitations. Okay, that time obviously another material will be preferred. But by using plastic composite also, you can carry high weight. Okay, it is not as such that it is only used for the carrying low weight only. Medical applications. Your tablets. Okay, if you see the covering of the tablets, the tablet pouch, if you purchase in a bulk, you will get a uh, strip tablet strip. It is made out of the plastic. Tablet covering, it is also made of the plastic. Even even soluble type tablets you are getting, have you seen that red and blue color tablet? Not a powder type tablet, red and blue color tablet. It comes in the cylindrical format, and inside that powder like structure is there. But we take that tablet as it is, because it is a soluble type plastic which will not harmful to your body. Okay, so that tablet is also coming with the plastic. Pill casing or even pill is coming with the plastic. Plastic implants, a major use nowadays. Major use. See, usually in the old days, um, metallic implants are used. Have you got the meaning of the implants? Implants means if suppose your any bone will be fractured, So in that, replacement will not be exactly bone. It will be made out of this artificial material. So usually, in old days, mostly medical practitioners are using these implants made out of the iron rods. Okay, have you seen, if your hand will be fractured, rods are inserted. Rods are inserted. Okay, so that rods nowadays they are using of the plastic because it is having inert nature. Inert means it will not react with chemicals that are available in your body. If you use the implants made from pure iron or copper, it will start reacting with your body. Okay, so that the plastic implants are preferred as compared to the metallic implants. PPE kit, popularly known. Okay, no one can forget throughout the life now this PPE kit used mostly. Actually, it was not. It is not like that. It is only used in a corona. From old days, it was in use. Okay, but mostly the medical practitioners are using hand gloves and the mask. They were not using this PPE kit, but nowadays you will see everywhere uh, this PPE kits, totally made up out of the plastic. Hand gloves made out of the plastic. Injections. If you see the syringe of that injection, okay, not that front syringe. Obviously, it is a metallic syringe. The basic cylindrical part made out of the plastic. Blood bags. Already I have told you. Heat wall. Okay, actually it is a hurt wall, right? That hurt walls, when bypass surgery is carried out, that hurt walls are placed. That are artificial hurt walls are made out of the plastic. It is again a kind of implant. Optical glasses, already I told you, it is also made out of the medical. Electronics, electrical and electronics applications, so many. Starting from resistors. If you see any electronic product, if you open it from the back, you will see a small resistors made out of the plastic. Fire safety walls, television set. See, in the television set, only if you remove that glass, remaining entire part is made from the plastic. Electronic equipment, so many. I told you, personal computers, laptops, everything. Okay, that is made out of the uh, plastic. Mobile casings. Again, here also, if you remove the mobile glass, remaining entire part is made from the plastic. Tablet casing, mobile or tablet casing. And last one is the furniture applications. Furniture, household applications, so many. Hmm? Now, you will not see uh, wooden chairs. Still, you are finding it, but very less. You will not see. In old days, there used to be a wooden furniture, wooden chairs, wooden home decors. But nowadays, you will find wooden chairs and sorry, plastic chairs, plastic tables, plastic home decors, plastic interiors, everything because of the less cost and good surface finish. That's the thing. Okay, so in the furniture also totally, even see partitions. You see, if you see the IT industries also, they are using the partitions. They are not constructing the entire structure out of the bricks or cement concrete. Okay, only the major column beams are made out of the bricks and cement concrete. Internal structure is made from the partitions, which can be removable type. Anytime they can remove it. Okay, they can expand it, they can contract it. Okay, so that is made out of the plastic. So the partitions, furniture partitions are also made out of the plastic. Okay, so plastic. So all the applications we have seen. So from last 7 lectures, you are listening only the word plastic. Okay. So these are the applications. Just see it once again, and then we'll close it. Agricultural applications: major greenhouse, low tunnels, mulchings, plastic reservoirs, irrigation systems. Okay. Even see, in the plastic reservoirs, if you see artificial lakes, in Marathi we call it as शेततळे. Okay, what is there? A plastic paper is there. Plastic paper is kept in that, and on that that water is poured there, and that plastic paper life of the plastic is used to be more than 10 years. Getting it? Okay. So there also this plastic is in a use. Silage, I told you the concept of the silage storage purpose. Like other plastic applications, crate. It is shown here crate, but there are so many. In packaging, PET bottles, carry bags, food packagings, HDP, LDP packagings. In transport, wipers and driver participation, steering wheels, mirror cases, interiors, brakes, cables, headlights, medical applications, pill casings, pills, Ppe Kit, injections, optical glasses, in electronics and electrical registers, then your switchboards, fans, and last one is the furniture, that chairs, tables, partitions, home decors, and interiors. Okay, so that's what about the plastic, the introductory part. So I think it's over now. Let's check out once again. Okay, so we have seen definition, classification of plastic material, properties of plastic applications, testing methods for plastic, additives, monomers, polymers, and this process, that is polymerization, and applications of plastics in a various areas. Okay, so that's what about the plastic. Quite theoretical chapter, but it was an introductory, just to give the introduction or the background of the plastic, that how the plastic came into the picture, what are their uses and its properties, some chemical nomenclatures, the process of making like polymerization, and some basic structures like monomers, polymers, and the basic applications, right? So we'll conclude here our first unit, that is introduction to plastic, and from next lecture onwards we'll start with the second unit. Okay, slowly we'll have to deal with the numericals also. When the mold design and it will start, we'll have the numericals also. So first couple of units are theoretical units, then we are having numericals. Okay, uh, still whatever we have seen, it was not actually an engineering, it was a basic knowledge. The engineering, actual plastic engineering, will start from the second unit, right? When how the processing of the plastic is carried out. For that, what are the requirements, the temperature requirements, flowability, mold design, mold requirement. That is actually a plastic engineering. Okay, analysis is our part. So the first chapter was only an informative chapter, right? So we'll stop here for today, and in the next lecture we'll start with the second unit, and maybe before that I'll release all the lectures through that Google Classroom. You will get notification from that. So recorded lectures, you will get it. Just if you are having any query, first of all go through that video lecture. Still if you will not resolved, then be in touch with me. We'll get it resolved. Okay, and right, so we'll have a small test also, MCQ based test. So immediately it will get revised, right? So maybe before the next lecture we'll have a short test, maybe or 10 or 20 marks, and then we'll go for the second unit. Okay, so just just a bit. Okay, so drop your roll numbers in the chat box and then you can leave. Thank you so much for joining.
sir.
Yes.
Sir, can you send the notes PDF before test?
Yes, 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 obviously. I'll share.
Thank you.
Okay.